Now we're going to take a look at adding vectors that are parallel to each other. So let's take a look at example A, where I have two vectors going in the same direction that are parallel to each other. We're going to add them together using tip to tail. So I've made A red and B blue, and when I put them tip to tail and then I connect the tail of A to the tip to B, I basically get one long vector. So my resultant is still parallel. Basically, my magnitude for this one would be the sum of the magnitude of A plus the magnitude of B. So let's write that down over here on the other side of our sheet where it says what happens when we add parallel vectors that are going in the same direction. So if A and B, I'm going to add my arrows after, are in the same direction, oops, then A and B, sorry, A plus B is going to go in the same direction. Okay, and let's make sure that we put our arrows to show that those are vectors. The other thing that we're going to write down here is what probably is obvious from our picture there, but if I take the magnitude of A and I add it to the magnitude of B, and again, those are just the lengths of the vectors, this is going to be equivalent to the magnitude of the resultant vector A plus B. Okay, now let's take a look at vectors going in the opposite direction to each other. So still parallel vectors, but in the opposite direction. You can see that A is going in this direction and B is parallel but going in the opposite direction. So I'm going to start here by drawing the resultant. So I'm going to start by drawing my vector A, and then using tip to tail, I'm going to add B kind of on top of vector A. So here's my vector A that I've drawn. Now I'm going to draw vector B. And this vector is actually on top of A. I just kind of drew it off a little bit to the side so that we could see both of those. And then I'm going to add my vector A plus B, so the resultant. And remember, this goes from the from the tail of A to the tip of B. So from the tail of A to the tip of B, and just think about these being kind of all on top of each other, is from here to here, okay? And so this would be A plus B there in blue. So I'm hoping you can see from the diagram that the direction of that resultant vector A plus B really depends on which vector A or B is longer, right? So in this case, A was longer than B, so A plus B is in the direction of A. If B was actually longer than A, then it would be going in the direction of B. So we're going to go over and write these conclusions over in our box where it says opposite direction. Okay, and again, these are parallel vectors, but with opposite direction to each other. So if I have the magnitude of A greater than the magnitude of B, okay, and that's the diagram that we have, the direction of A plus B, that resultant vector, is the same as A. Okay, we also know in this case that the magnitude of that A plus B vector is equal to the magnitude of A subtract the magnitude of B. Okay, and again, hopefully you can see that from our picture. And so this example C that we have down here, you can see that we have the same idea, you know, opposite directions, but parallel vectors. And so but in this case, vector B is bigger than vector A. Okay, so let's go ahead and we'll draw our resultant vector. So this is B plus A, or remember, this is A plus B. Okay, these two are equivalent. Okay, so you can label it either way. And we can see that that magnitude is going to be B subtracting A. Okay, so let's write down the conclusion for this one. So if our magnitude of A is less than the magnitude of B, then A plus B is in the direction of B. So it's going to be in the direction of the vector that's longer. Okay, and then we have that the magnitude of A plus B in this case would equal to the magnitude of B subtract the magnitude of A. Okay, let's take a look at the case where we have parallel vectors, opposite directions with the same magnitude. So here's our example with vector A and B. If I were to draw kind of tip to tail and put them on top of each other, so for example, if there's vector B on top there, you can see that when I go to draw the resultant, I have nothing left, right? There's nothing to draw here. And this is where that zero vector comes into play, okay? So what we have when we have no magnitude is we have that zero vector. So in this case, A plus B would equal to that zero vector. Now, something to note just in your definitions that any vector plus the zero vector is the same as, again, the zero vector plus that vector. Those are the same. And that just equals our vector A. So adding the zero vector, subtracting the zero vector, it means that we end up with our original vector. Okay, the other thing to note is that if I add A plus negative A, that gives me the zero vector, right? And in this case, B, like up here in our example, that vector B is equivalent to negative A, right? It's the same vector, but opposite direction. Over in our box over here, when we're talking about the zero vector, we're going to write our conclusion. If the magnitude of A is equal to the magnitude of B, and vector A and vector B are in opposite directions, then A plus B is equal to that zero vector, and our magnitude of that zero vector is equal to 0. Okay, or you could even write, which seems obvious, but the magnitude of a zero vector is 0.